Okay, today we're covering measures of central tendency and dispersion, which are basic units of statistics. Most of these you're already familiar with, especially for your measures of central tendency. Now, central tendency means where the center tends to be. Okay, so if you got a group of data, where's the middle of it? That's what central tendency is measuring. And so we have three types of measures of central tendency. We have the mean, which you all might already know as, it's another way of saying the mean, the average. And we have a symbol for the mean. It's called x bar. It's written as x with a little bar over top of it. And so we already know that we calculate that by adding up all the numbers and dividing by how many there are. Right? Then you have the median. What's that?
From least to greatest.
First we order the numbers least to greatest. Then we take the middle number. What happens if there's two middle numbers?
Then you add them and then divide by 2.
So if there's two middle numbers, you take their average. So that would happen whenever you have an even number of numbers. Okay, there'd be 2 in the middle. And then we have the mode. What is the mode? Yes. Yep, the most frequently used number. Now, that must be more than once. Okay, if every number only appears once, there's no mode. If more than one number appears the same number of times, okay, like suppose 2 and 3 both showed up 3 times, they would both be the mode. Okay, you can have one mode, you can have no mode, you can have more than one mode. It all depends. So let's take the measures of central tendency for this first set of data, which is the height of 8 waterfalls in the state of Washington in feet. And those numbers are 1,000, 1,000, 1,181, 1,191, 1,200, 1,268, 1,328, 2,584. So let's do the easy ones first. What is the mode? Liz? 1,000. Because that appears twice and no other number is repeated. The median, we want to find the middle number. So one way to do this is just kind of take one off the front, one off the back, one off the front, one off the back, one off the front, one off the back, until we got 2 in the middle. These 2.
Wait, so you don't have to do them least? Wait, no.
They already are least to greatest. Yep. So if they weren't least to greatest, we'd have to put them in order. But since they're already least to greatest, saves us a little bit of time. So what's halfway between those two numbers, Maria? 1,195.5. All right, and the last one is the mean. So we're going to add all those numbers and divide by how many there are. What do we get?
You get 10,000.
You skip an extra day of school, you forget how to raise your hand. Yes.
10,752.
Say what?
10,752. That's way too big. Maria?
We get 1,344. It's 10,752 divided by 8.
Ah, you gotta divide by 8.
Say divided by 8.
You were about to say,
No,
but
you
you didn't. You left way too big of a pause there. Unless you're a bear, there's no reason you should have that large of a pause.
Yes.
All right. This makes sense?
Mm-hmm.
All right. So the question is, which measure of central tendency best represents the data? Which one is closest to the middle? Maria?
1,328.
1,320? No, out of these three numbers here,
Okay.
out of our mode, median, and mean, which one's best? Yeah?
1,195.5.
That one's the closest to the middle. That one's exactly the middle. But the question doesn't necessarily mean which one's closest to the middle. It means which one represents the data the best. So if you look at it, the mode is obviously way too small because it's the smallest number there. And the mean is bigger than most of the numbers. Okay? It's only smaller than the biggest number. So that doesn't fit very well. The median is right in the middle. That's the best measure of the middle there. Okay. So once we have measures of central tendency, we can learn measures of dispersion. There's two that we're going to cover in this class. Range and mean absolute deviation. The range is super simple. You take the maximum number, the biggest, and subtract the smallest. That's it. Biggest minus smallest. Then there is the mean absolute deviation. So mean, because we're going to use the average. Absolute, because we're going to use absolute value when we're just talking about distances. And deviation is how far away something is. So what we do is we take each number, the first number we would call x1, that's just our first number, and we subtract it from the mean to find how far it is from the mean. And we take the absolute value because we're not concerned if it's left or right. We just want to know how far it is. And then we take the next number and do the same thing. And the same with the third number. And we do that with all of the numbers up to the last number, which we would call x sub n, because that's the last number when there's n numbers. And then we divide by how many numbers there are. So basically what we're doing is we're taking how far each number is from the average, and we're averaging all of those distances. So it's the average of the distances away from the average.
And that's over n, which is how many?
Which is how many numbers there are. Yep. So let's just look at the last set of numbers that we had. And we will calculate the range and the mean absolute deviation for those numbers. So here's our last set of numbers with all the cross-outs and all that stuff. What's the range?
1,300.
Nope.
Oh. The biggest minus smallest.
Yep. 1,584. That's our range. The distance between the biggest and the smallest. Pretty straightforward? Now, we know from earlier that our mean was 1,000. Oops. 344. What we're going to do is calculate the mean absolute deviation. We do 1,000 minus 1,344, and we take its absolute value. And we do that again because we have another 1,000. Then we do 1,181 minus 1,344, and 1,191 minus 1,344, and 1,200 minus 1,344, and 1,268 minus 1,344, and 1,328 minus 1,344. And 2,584 minus 1,384.
Wait, so
And then we're going to divide all of those, that whole sum, by 8. Because there's 8 numbers. Yeah.
Ask the question. Everyone's wondering, is there a way to do this on the calculator?
Nope. The calculator calculates a different type of deviation. Yeah.
so with the mean absolute deviation, it's just all of the sequence of numbers. And
Yep.
There.
Yep. That's it.
Okay.
Is there anything on here that can
No.
do absolutes?
Yeah, there's an absolute value button on there. Yep, it's under math. You go to math and then over to number.
Absolute values don't even really matter because it's just if it's a positive number, it's
Yep.
the same. If it's a negative number, it's just
So 1,000 minus 1,344 is negative 344, and its absolute value is 344. So we're going to have 344 and 344, and then 263, and then 253, and then 144. That's a 1,200, not 1,100. And then 76, and then 16, and then 1,200. So you got to add all those up and divide by 8.
2,000. Okay. You get 330.
So you're telling me when you add them all up, you get 2,640?
Yep. And then divided by 8, you get 330.
There's your mean absolute deviation.
Wow.
So that tells you how spread out the data is. The average distance from the average is 330.
no, that tells us that we're all going to fail this quarter in algebra.
You're not going to fail.
Guys, all it is just like the
That's-
mean.
You telling me you don't know how to subtract and take an absolute value? You just told me absolute value was easier.
I know
And now you're
that
telling me you don't know how to
there's
subtract
a lot of it.
or divide? Oh, it's a lot. So it's not that you're incapable, it's that you're lazy. Got it.
Yeah.
Got it. Yes.
What does the thing that always I get mixed up with? What those two lines mean?
Absolute value.
You're gonna
Well,
have
that's
fun.
something-
That means you just make it positive. Okay?
So if you get negative,
You just make it positive.
Positive.
Yep, that's why 1,000 minus 1,344 is negative 344, but the absolute value is 344.
Because it's just the distance from that number
Yep.
to 0.
Okay.
That makes sense?
I like this homework.
Any questions?
No, sir.
All right.